This one can be treated as universal set. And set A, set 4, 5, 6, 7. We have more laws, but first of all, we verify with the help of Venn diagram or prove few of these, not all. I shall discuss few. Students, learners are to prove themselves the others. What we have done, stepwise. For the left hand side, we have drawn first two diagrams. In the first diagram, we have marked A. In the second diagram, we have marked B. And in the third diagram, that is the final one, for the left hand side, A intersection B is shaded. Universal set is a set which contains all the sets in our discussion. For example, if we discuss the sets of different sets of numbers, say set of positive numbers, set of negative numbers, set of fractions, set of positive as well as negative fraction, then we can say easily that these sets are all subsets of the set of reals. Therefore, in this discussion, we can consider set of reals is an universal set. The set of all sets in our discussion is called a universal set. Example, sets of real numbers, that is can be treated as universal set while we are considering the set of positive, negative, rational numbers. These two things I have not discussed in the last class or last episode, power set of a set and universal set. The last operation is complement of a set A. If A be a set and the corresponding universal set say S, then complement of set A Set A denoted by the symbol denoted by A, we write C at the top, or A bar, or A dash. Complement of a set A has three symbols, and we define that is a set having elements x such that x belongs to S minus A. That means a set of elements which are not belonging to A, but let S be the universal set and A be the set. I have drawn the Venn diagram. Here S is the universal set and A is the set. Then complement of set A is the set. The shaded region is the complement of the set A. Shaded region is A complement. We can take an example. This one can be treated as universal set. And set A, set 4, 5, 6, 7. Then complement of A is S minus A. Therefore, that set will be now we discuss some properties. Already we have discussed set operations. I write serially A symmetric difference B, that is equal to A union B minus A intersection B. From the diagram, symmetric difference is the union of A minus B and B minus A. Now it is clear from the diagram that symmetric difference of AB, the whole minus this unshaded part, that is A union B minus A intersection B. Then number 2, null set is subset of any set. Number 3, Any set is subset of itself if A is subset of B and B is subset of C, then A is subset of C. And already I have stated earlier, if the two sets A and B is such that A is subset of B and B is subset of A, then the two sets are equal. Next observation or property, difference of two sets A, B, that is of course subset of A, and B, difference A is subset of B. And we can write A minus B as A minus A intersection B and B minus A, or we can express that A union B minus B. And properties or results related to complementation are number one, complement of a set A is the set itself. Number two, union of set A and its complement is the universal set. Number three, A intersection A complement will be equal to null set. Number four, complement of null set equal to the universal set, and complement of the universal set, that is null set. These are the results related to complement of a set. Now we shall move to the laws of set algebra. We shall now write down serially the laws of set algebra, and also we shall prove and verify few of the laws. First, let me write down the laws serially. Laws of set algebra. Number one, commutative law. A union B equal to B union A. Number two, A intersection B equal to B intersection A. Associative law. A union B union C is equal to A union B union C related to union A intersection B intersection C is equal to A intersection B intersection C. Then distributive law. You can say also laws. Number 1, A union B intersection C is equal to A union B intersection A union C. Number 2, A intersection B union C equal to A intersection B union A intersection C. Number 4, De Morgan's law. A union B whole complement, that is equal to A complement intersection B complement. Number 2, A intersection B whole complement equal to A complement union B complement. We have more laws, but first of all, we verify with the help of Venn diagram or prove few of these, not all. I shall discuss few. Students, learners are to prove themselves the others. Now I take one of the first law, commutative law. First I verify. With the help of Venn diagram. Actually, for learners, students, some students think that we can prove with the help of Venn diagram, but not that. Venn diagrams are used for verification purpose. Remember this thing. When you will be asked to prove that, then you cannot use Venn diagrams. Now, I prove or verify the second one. Actually, here we are using step-by-step method. I have drawn the rectangles which indicate universal set. Now, for LHS or RHS, we are showing step by step. First, I draw two sets A, B. Since A intersection B on the left side, we first mark the set A. This is figure 1. A is shaded. Figure 2, we said here B is shaded, means the shaded region indicates B set. Then on the right part, B intersection A, therefore we have to set B first. I call it figure 4. Figure this is figure 3. Actually, from this, the common region A intersection B is shaded for this figure. Now, for the right part, already I have marked B set. B is the shaded region. Then figure 4, this is figure 5, A is shaded. Now, it is clear that the intersection part will be this one. Therefore, next diagram will be this one. From these figures, it is clear that A intersection B as well as B intersection A are equal. From figure 3, it is clear that A intersection B will be equal to B intersection A. What we have done? Stepwise. For the left hand side, we have drawn first two diagrams. In the first diagram, we have marked A. In the second diagram, we have marked B. And in the third diagram, that is the final one, for the left hand side, A intersection B is shaded, and for RHS purpose, B set is shaded in the first diagram, and then A set is shaded, then the final diagram is this. Therefore, we find the final diagram in both cases same. Therefore, we conclude A intersection B equal to B intersection.